Okay, so all we said, summary notes today, somebody in, all we said is that for a function, there can only be one output for every input. Now, the output's here repeat, not the input. So in this case, f of x equals x squared, that's how we read this function. If I want to plug in 3, that makes 3 my input. The way we would write that is f of 3, instead of the x, now we put in the input that we want to replace the x with. F of 3 is equal to 3 squared. So if we do that math, 3 squared is 9. So f of 3's output is 9. Right? So it's like in the vending machine. I put A1 and I got a Snickers. Okay? What if I plug in, what if my input is -3? So f of -3 is equal to, you got to be careful on your calculator, use the parentheses. It's parentheses, -3, close parentheses, squared, or you're going to get the wrong sign. But -3 squared is also +9. So that's kind of like, I press A1 and get a Snickers, and I press B1 and get a Snickers. It's still a function. It's okay to the output repeat. Anaya?
What a negative numbers do you want us to put? All we saw that negative numbers do you want us to put?
Yeah.
Okay.
Because you have to do that on the calculator. If you want to try it right now, you'll see, Maxwell got this on your backpack. Okay. I mean, we have it. And you don't have to ask to get it on your way out, just grab it, okay? So, I forgot, yeah, so when you're in with a calculator, if you have your calculator, you might want to practice this, because it's definitely not -9. So if you plug it in and you get -9, you know you've done something wrong. Because 3 times 3 is +9, -3 times -3 is also +9. So you got to be careful on that, all right? So f of 5 means we plug in 5 into our function. When we square 5, we get 25. The input is 5, the output is 25. So that is an example of a function. This is an example of an expression or an equation that is not a function, because the x's are going to repeat. And I don't really like this. All right. So I want you to see, so this is kind of backwards. Instead of f of x equals x squared, they're saying the output squared is equal to the x. So what would the x be? So, for instance, if the input squared is 9, that could be 3, right? But it could also be -3. So that would be like, I pressed A1 and I got a Snickers one time, and I pressed A1 and got a payday a different time. Like, you can't do that. That makes it not a function. That makes it not a good vending machine, and it makes it not a function. Every time I enter a number in a function, I should get the same thing. It's okay for 2 different inputs to give me the same output. It's not okay for the same input to have 2 different outputs. So the inputs are repeating. Function notation, we've been talking a little bit about that already. I wanted to point out that if we had this equation, y equals x plus 5, this function down here is just the equation written in function notation. So that's the same thing as f of x equals x plus 5. F of x and y are the same thing. Okay? That's all. The function notation is just written more in input output. It's not really more. I think it's more targeted to real world problems. If I plug this in, what am I going to get? I don't know why. I feel like it should be the same. But no. All right. So f of x is the output, which is ready right when I'm ready? So what this says is that we're adding 5 to whatever our input is. If our input is 5, then our output is 5 plus 5. If our input is 20, then our output is 20 plus 5, or 25, right? It can be, we can use any label we want, or any variable we want. We're talking about x's and y's. But if we designate p as our input, it's okay to use the letter p. If we designate, if we want to use function g instead of function x, we can say g of x or g of p. It doesn't have to be specific letters. The f is the most common function label, and we typically use x for the input, but it does not have to be that way. So f of x is read the function of the function f of x or just f of x. All right, so we've got 3 examples to work on. We need to be able to write the function, and in some cases we need to be able to evaluate the function for a given input. So this is Johnny triples his money by investing. What does it mean to triple something? Multiply by 3. So let's make a note. That's what I did up there, times 3. And then he pays $2 in capital gains taxes. If I pay money, am I multiplying the money? Am I dividing it? Am I subtracting it? So that pays $2 really means minus 2. Make sense to everyone? All right. So in capital gains taxes, when he sells those investments. So the value of his investment is going to be equal to the amount of money he starts with, and they call that his principal or his initial investment, so we'll just call it principal. He multiplies it by 3, and then he subtracts 2. Okay? So anytime you have a word problem, you want to kind of break down what's happening, and then you want to follow the steps. You're going to always start with your variable. And in this particular example, we know we're multiplying the starting amount by 3, and then subtracting a flat 2, not 2 for anything, it's just minus 2. So we're multiplying it by 3, and then we're subtracting 2 from that result. So if we're actually writing a function, it's going to be f of x, because we're using x for our input, and it's x times multiply x times 3, and then subtract 2, but that's not really what it's going to look like. This is the formula it look like. So these are the same things. If you're asked to write the function, you don't have to give me the first one. It's just showing how our steps work. So this would be step 2 and step 3, but then this is written the way we would normally write the function. So if his initial investment was $100, we could do f of 100 equals 3 times 100 minus 2, and you'd have his total, his net investment, or his profit. Okay. Evaluating functions just means plugging in the given value for the variable for the input, and then simplifying. Plug in and do the math, basically. Do whatever the function tells you to do. Can you not see it right here, sweetheart? Well, you can put a suggestion if you prefer. I can take a picture anyway. You don't want to get that downstairs in front of the student. All right. Y'all talk with me? Example 2. Marissa earns $18 and hour tutoring. That's 18 times the number of hours you tutors, right? 18 times. At the community center, on weekends, she is paid a bonus of $15 per shift. So, times 18, and that's gonna be plus 15. How much money would Marissa earn for working 6 hours on a Saturday? If X is the number of hours worked, solve the functions, which means you must have to write the function, right? If it says solve a function, you have to write the function first. We need to know that the variable here, X, is the number of hours worked. And the output, the F of X, is going to be the amount of money she makes working that Saturday shift. So F of X in this case is the money she makes for the Saturday shift. That's the output. So here it says X is the number of hours worked, so $18 per hour, so that's 18 times X. So we're going to start our function though off with F of X, because we're using the variable X. If we were saying H is the number of hours, then this would be F of H, Jay. Does that make sense? That letter doesn't really matter. That is our input. So now we have 18 times the number of hours plus $15. She does not get $15 for every hour. She just gets $15 per shift because it's a flat 15, right? So if she works 1 hour, it's 18 times 1 plus 15, $33. If she works 5 hours, you plug in 5 for us. Make sense? Alright, so now we've got the, that's our function. Now it's just substitute for the input values. So they wanted us to evaluate the function when X is 6 or 6 hours. So we have to know that's what that means. We're gonna plug in, now we're gonna write instead of F of X, we're writing F of 6, because that's what we're plugging in the X spot. So 18 times 6 plus that flat $15. Very good. Now we're going to simplify. Perfect. Now 123, that should not be the form your final answer is in. You should tell me that she makes $123 for this shift or $123 for the Saturday shift. Something like this. You should let me know what that 123 represents. You should let me know that you know it and that represents the earnings, what she made for working at the community center on this Saturday. Something, it doesn't have to be exactly that, but it's going to be something so I know what to understand what that number represents. You guys ready? Can I go to the last one in a minute? In a few seconds. If you're not taking your notes in pencil, let's try to start taking notes in pencil. If for no other reason than because sometimes I mess up. Okay. And it's math, we really should be working with pencil most of the time. Especially when we're doing the practice problems. If you want to do the definitions and the words and stuff like that, then that's fine. But anytime we're doing these kind of practice problems, let's do them with pencil. And domain range. Definitely something that you work with in algebra. Remember, an ordered pair has a domain and a range. So the coordinate pair 2, 3. 2 is a domain, 3 is a range, right? The X and Y values. So the domain is a possible set of values that you can plug into your function. So you might think, well, I can plug any number into a function or an equation. And that's true. But in a real-world application of this function, we're talking about the number of customers. Can you have negative customers? No, right? So that's something. Can you work a negative number of hours? You cannot, right? So those are some things we want to think of. What are the range of values that are appropriate for us to use as inputs in our function? And then what is the range of values that the outputs could be based on any constraints or limits that might be placed on it. So let's go ahead and look at our example. I think you understand a little more what we're talking about. Armando works at a street sign, as a street sign advertiser for a local restaurant. He is paid $10 a shift, plus 50 cents for every customer who comes into the restaurant during the shift, up to a maximum of $100 per shift. Determine the domain and range of the function that describes Armando's daily wages. Well, first let's go ahead and write the function. We know he basically, look at this sentence. If you're wondering how to write equations or functions, sometimes they almost tell you exactly right what to write. So if you'll look here, $10 a shift plus. So it makes sense that it would be 10 plus, right? 50 cents for every customer. So we're going to say that X is what? Well, X is the number of customers, right? So we would say that plus 0.50 times the number of customers. That's how much Armando would make, depending on the number of customers he has. So we write that in function form, since we defined X, the number of customers as X, our function is going to be f of X equals 10 plus 56 per customer. So if we want to determine the lower and upper bounds of the domain, so what's the smallest number that makes sense for us to plug into this function? What's the smallest number that makes sense for us to plug in? 1. What if we didn't wait on any customers? Wouldn't 0 be an appropriate number? The 0 is actually our lower bound. We are constrained by the fact that we can't have negative numbers, right? But really, no negative input values. But the lower bound is actually 0, because he could go to a shift and not serve any customers. That is feasible, right? If not feasible, then he could wait on a negative number of customers, or even a fraction of a customer, but he could wait on 0 customers, right? So 0, that means he doesn't wait on anybody, no customers. Now, upper bound, it does not talk to us about a maximum number of customers. So we're going to say he has no limit or no upper bound on the value that we could plug in for X, because he might wait on 2 customers, he might wait on 100 customers. Would it be hard? Yep, it's going to get harder, but in theory, there's no limit to the number of customers he can wait on. Does that make sense? So if he waits on 0 customers, how much money is he going to make? $10, that's right. So if he waits on 0 customers, we'd say that X is 0, so we plug in 0 for X. And when we do, we get X equals $10. So 0 times the number of customers is going to give us 0. But it always makes that $10 even if he does it for every shift. So if he waits on 0 customers, that's how much he makes. So the lower bound of his output, he can't make less than $10, right? Because he's going to make that $10 no matter how many people. So what's the most money he can make? What's his upper bound of output for this function? Not 110. It says, yeah, so it's going to be his per shift, because that's going to include his $10, right? So the maximum boundary, the maximum output of, okay, his lower bound is 10. His maximum or upper bound is at $100. And that is his maximum salary per shift, and that has to include his $10. So it's possible, if he waits on 200 customers, if you plus 200 in, you would get $110 for his estimate you make for the shift, but he'd be allowed to make $110. So if you plug in a number that's more than 100, your answer has to be 100. Kind of like that maximum taxable income right? For the maximum amount that he can make. So if the number is say it's 110, you gotta go, oh yeah, but the maximum he can get paid is $100. Does that make sense? Alright, and you should be able to write it as an inequality. So its input, the domain has to be greater than or equal to 0. So you have to be able, the only thing you can plug in is a number that's greater than or equal to 0. Technically, that should say integers greater than or equal to 0, because you're not going to have part of a person, right? You're not going to have a half of a person, but that's okay, half of a customer. Now our output, what is the range for the range of values or the inequality that we could write to represent the range? Remember, the range is the possible outputs for the function. So what's the lower boundary for the function, for the output rather? $10. What's the upper boundary? $100. So you'll remember, it's called compound inequality. You learned this in algebra. This means he's gonna, the possible amount of money he can make is gonna be greater than or equal to $10 and less than or equal to $100. Another way that might make more sense to you, f of x is greater than or equal to $10 and f of x is less than or equal to $100. So on the number line, it would fall in between the 10 and 100, and it would include the 10 and 100. We have 10 minutes, 8 minutes for you to get back up 2 minutes early so you can start working on your worksheet. Please don't pack up before 48. Jonathan? Yes.
Do you have a new worksheet before we have a
We have a review tomorrow. It's not technically a worksheet, but it'll be a review of the test. I'm sorry, you said one, Jonathan? Is that right? Yeah, so you have a review. Your test is going to be in Canvas. It's going to be an online test, and your review is also going to be, I think your review is going to be a quizzes, but it's going to look just like your online. Is it an emergency?